Now we're going to look at the wave equation and the electromagnetic spectrum. You have to be able to derive and apply the relationship between wave speed, wavelength and frequency, otherwise known as the wave equation. As you know that speed is the distance travelled per unit time. In other words, distance divided by time. Now let's say we have a wave which passes. How long does it take for that one wavelength, lambda, to pass? How long does it take for that distance to pass? Well, you know that the time taken for one wave pass is the time period. So you know that the time is equal to t, which is the time period. And how far does the wave travel as it passes? Well, we're talking about one wavelength. The distance travelled by one wavelength when it passes completely is going to be, of course, one wavelength. So the distance is going to be lambda, the wavelength. The time taken is going to be the time period. So now the speed we can write as distance over time is equal to distance, which is one wavelength, divided by the time, which is one time period, when one wavelength passes. However, we do know that there's a relationship between frequency and time, that the time period is equal to 1 over the frequency. In other words, frequency is equal to 1 over time. So we can substitute, instead of t, or 1 over t, we can substitute f. So speed is equal to lambda times by f, or v is equal to f lambda, otherwise known as the wave equation. Now we look at the electromagnetic spectrum. In the syllabus it states that you should know that all the electromagnetic waves travel with the same speed in free space in a vacuum, 3 times 10 to the 8 meters per second. You need to recall the orders of magnitude of the wavelengths of the principal radiations in the electromagnetic spectrum. So we have to focus on wavelengths. Let's start with visible light. You need to know that blue light is 400 nanometers. You need to know that red light is around 700 nanometers. You need to know that green light is around 550 nanometers. Let's look at the whole picture. We have to consider the wavelengths, remember? Wavelength is from 700 nanometers down to about 3 times 10 to the minus 4 maybe. Wavelengths. The wavelength of radar is from 2 times 10 to the minus 4 up to about 3 meters. The wavelength of the microwaves in your oven are about 60 or 70 centimeters. Radio waves go from around 3 meters to 3 times 10 to the 4 meters. Ultraviolet is beyond the violet end of the spectrum, so it's less than 400 nanometers and goes down to 10 to the minus 9 meters. Here we have X-rays, and gamma rays is around 3 times 10 to the minus 12 meters. This is the kind of picture that you need to have.